Here we will discuss two questions for two further experiments, namely what changes happen on the graph and how do gas volumes compare. For the first of the two questions, we know the mass of aluminium is the same in both experiments 1 and 2. But we are told the concentration of the acid is doubled to 2 moles per decimeter cubed. This graph in orange is the one that was given to us for the first experiment, and we need to draw the graph for the second experiment. The steepness of the graph indicates the rate of production of hydrogen and the rate of the reaction. Now we know that the rate of a reaction is influenced by the concentration of solutions, the pressure of gases, temperature, the surface area of solids, and whether a catalyst is present or not. In experiments 1 and 2, the concentration of the acid differs, and so this will affect the rate of the reaction and how quickly hydrogen is produced. In the first experiment, the concentration of acid is lower. This will result in fewer effective collisions per second between the aluminium and the acid particles, and therefore the rate of the reaction is slower. While in the second experiment, the concentration of acid is higher, which will result in more effective collisions per second between reactant particles. And so the rate is faster. We said that the steepness of the volume time graph indicates how fast the hydrogen is produced and indicates the speed of the reaction. So since the rate of the second experiment is higher than the rate of the first experiment, the graph for experiment 2 will have a steeper gradient for the duration of the reaction. Now, it is the amount of limiting reagent which determines the amount of product that can form. In both experiments, there is the same amount of limiting reagent. And so both experiments will produce the same amount of hydrogen gas, just at different rates. And this can be shown on the graph by the same volume of hydrogen at the maximum point. Then we have to see how the volumes of hydrogen produced in the first and third experiments compare. We are told the same mass of aluminium is used in each, but that a strip of metal is used in the first, while powdered metal is used in the second. We said earlier that the surface area of solid reactants affect the reaction rate. Compared to powdered metal of the same mass, a strip has lower surface area as there is just one big particle, which means there are fewer aluminium atoms exposed to hydrochloric acid, and so the frequency of effective collisions is lower. And therefore the rate is lower or slower. However, for powdered metal of the same mass, there is a much higher surface area as there are many small particles. As a result, the frequency of effective collisions is higher, and so the reaction rate is faster. So we know the rate of experiment 3 is much faster than the rate of experiment 1. But how do the volumes of the gas product compare? Again, it is the amount of limiting reactant which determines the amount of product that can form. And we have the same amount of limiting reactant in both experiments 1 and 2. And so the same amount of gas will be produced in each experiment, and the volume of gas produced will be the same. The only difference is that this gas is produced at different rates.